Okay, back to the book. Geotrig, outline 27. We're going to talk about the signs of trig functions. So we've already talked about, it's been a while since we were in the book because we went and took all the log stuff. We've taken the sine of 30 degrees, right? We've done that before? And we've gotten things like 1/2 because you got your reference triangles. So technically, there should be no issues with sine, cosine, or tangent of 30, 60, 45s, or even the 90s. Right, of 90? Most of those, if not all of those, you should know, almost by heart even. But if not, we draw reference triangles, we write SOHCAHTOA, we're good to go. Well, guess what? There are an infinite many angles around the circle, both positive and negative, negatively, that we can find sine, cosine, and tangent for. And they are not always going to be positive. And so we remember this nice little phrase, all students take calculus, because it allows us to follow the quadrants counterclockwise, as you can see here, and it allows us to know which trig function is positive in which quadrant. So starting off with the first quadrant is all, and then students take calculus. It's a nice little phrase because in the first quadrant, A stands for all, because all trig functions are positive in the first quadrant. When I get to the second quadrant, it's students, and students is the S. The S is for sine. Sine is the only trig function that's positive in the second quadrant. Third quadrant, take T, tangent. And C is the fourth quadrant for calculus. It's cosine, so cosine is the positive one. If you don't like all students take calculus, you can say all schools torture children, if you would like to say that instead. Any way that you can remember that, hey, if I am in the third quadrant, tangent's positive, but sine and cosine are negative. Now wait a minute. If sine and cosine are negative, do we remember that tangent is sine over cosine, or we did not learn that yet? Tangent is sine over cosine? And a negative divided by negative is positive, and that's why tangent's positive. A positive divided by negative is negative, or a negative divided by positive, vice versa, negative. And that's why the tangent would be positive or negative in those quadrants. Any questions? So, we also have something we call related angles. One thing that we have to realize is that all angles are going to originate from the positive x-axis. Okay, don't put the little arrows in there. We'll talk about that in a second. But we always want to start here at this positive x-axis, and I will go up and rotate counterclockwise, or go down, which is clockwise. So going up is a positive angle, going down will have a negative angle. And it says any angle that terminates in a quadrant other than the first is what we call a related angle. I'm going to refer to that as reference angle. It has a reference angle. This reference angle that we're stating here is always going to be positive. It's always going to be acute. And it's always between where you stop and the closest x-axis. So that's why there's little blue arrows in there, and this one is not supposed to be a connected blue arrow. They just originate from the same place. So, each one of these, and I'll change the colors so that we can see them, is that, let's talk about this one first. Okay, so this bottom arrow, it's purple now. What you would actually think of is that's something like about 300 or 315 degrees. Can you guys kind of picture that? So what that means is that I actually would take a 315 degree approach to get there. This will have a related, what we will call reference angle. And that reference angle, guys, is this thing right here. The angle, that's the leftovers. How much more would it take for me to finish to get to the x-axis? Or sometimes, how much further have you gone? It matters what quadrant you're in to think of this. So since we're in the fourth quadrant, we want to know what is this angle here. What would be that amount left over? Or not left over, but needed to get to the x-axis. If you went 315, how much more to get to 360? 45. So 315 degrees has a reference angle of 45 degrees. Let's try this again. Let's talk about this one in the second quadrant. What if I said this angle was 150? What would the reference angle here be? Essentially, what would it take to get to the x-axis? The x-axis is how many degrees total, straight across? It's 180. So if I'm at 150, how much more is it to 180? It's 30 degrees. So it has a reference angle of 30 degrees. Are we getting this? Okay, let me change the color one more time. Green now. So now I'm at the green. Let's say that spin, whoops, from the positive x-axis to here. Let's say that was 240. What's the reference angle? So, what would it take to get back to the closest x-axis, guys? It's not 120. To get to the x-axis, guys, I actually want to get back to this x-axis. So what is this difference or distance here?
60.
Or angle? It is 60. So it has a 60 degree angle. The reference angle from 240 to 180 is 60. This is important. We need to know this because of what's going to happen next. Is everybody okay? They get this idea that I'm always going back to the x-axis. Sometimes I got to figure out what does it take, how much more does it take. Sometimes I have to figure out as how much further did I go. And again, that all kind of depends on which quadrant you're in. Here's one of something really kind of cool. It's not one of our options on here. Let's go with orange. Any angle here in the first quadrant, now I'm in the first quadrant. If I said this angle was 50 degrees, the reference angle is 50 degrees. Anything in the first quadrant is its own reference angle. Let me rephrase that. I don't want to necessarily say that is the reference angle because we could go further than 360, and at that point you got to take things in consideration, right? But if you're talking about an acute angle less than 90, it will be its own reference angle. So what we're going to do now is we're going to evaluate sine, cosine, tangent for any angle. These are kind of fun. These are fun. Now here's the cool thing about these ones right now. We know our reference triangles, so therefore we're only going to stick with the nice angles. Angles that form a 30, 45, 60, or 90. So that's what we're going to stick with. That's what we're going to do. So we're going to evaluate these trig functions. And the first thing you're going to do is draw a triangle for it. Draw that angle. Draw the angle, sorry. Graph it. If you have to go 130 degrees, draw yourself some axes and turn about, give or take, 135 degrees. Okay, that would be step one. So you'd be here someplace, yeah? Looking in that direction. I then want you to make a triangle with that point, the x-axis, which means you go straight down the origin. It forms a right triangle. That right triangle is going to create a reference triangle that you guys could technically fill in. Or at least tell me, hey, what's the reference angle so you can draw your reference triangles. That would step number 3, find the reference angle. What is this angle? Because that angle at the origin is your reference angle. We can use SOHCAHTOA then with our reference triangles. Make sure you watch your sign, because if you're in second quadrant, what's the only one that's positive? Sine. If you're in the fourth quadrant, which one's positive? Cosine. I skipped over third. And if I went to third? Tangent. If I went to first? All. Okay? So make sure that you guys remember, all students take calculus. That's what I meant by watch your trig signs. So, now, I got 3 problems up here. Each one handles pretty much the same exact way. We're just going to be in different quadrants. We're going to have different signs on things. All things that we're going to take in consideration. So notice, the first one is 4 times cosine of 35. First of all, it's 4 times the cosine. That means the 4 gets to stay out front. It stays, you leave it. I need to evaluate what's cosine of 135. So this is what I'm going to do. I will graph it. Here's my axes. I start at the positive x-axis. Which quadrant will I stop in for 135 degrees? Second quadrant. There I am. I'd be somewhere out there. So therefore, I build that triangle. And I ask myself, what's the reference angle to 135, which is here? What is it? 45. It's 45. So you know what? This is pretty cool. 4 cosine of 135 is equal to, guys, 4 cosine of 45. Or is it? You're in second quadrant. Second quadrant, cosine is? Negative. Oh, it's negative. So it's actually a negative cosine of 45. Guys, this is the power of reference angles. Is that the cosine of 135, which is a larger angle, can reference the first quadrant, which is a 30, 45, 60 angle, because it's the same exact number. It just could have a different sign. And that's why we needed to bring the negative sign with it. Everybody, do me a favor. Take out your calculator. We're going to use approximation for this one at first, because just to highlight the fact that they are the same. But eventually we will not be using our calculators when it's one of our reference angles. what happens to be the cosine of 135? So I'm going to leave the 4 away. Just don't worry about the 4 right now. What's the cosine of 135? 0.07? 707. Okay. What is the cosine of 45? And make it negative. Negative cosine of 45 is equal to the same thing. So it works. So now all you have to do here is say, wait a minute, that negative gets to move out front, doesn't it? So it's a negative 4 times cosine of 45. I'm not allowed to use my calculator because I want to have an exact answer. Take out your reference triangles. If you don't have them, build them again. It's a 45. What triangle should I draw? 45, 45, 90. Which is 1, 1, square root of 2. What is the cosine of 45? Cosine is adjacent over hypotenuse. So it would be 1 over the square root of 2, which we don't like. That would be negative 4 over the square root of 2, square root of 2 times, or divided by square root of 2, right? Fix that. Ends up being negative 4 square root of 2 all over 2. Divide negative 4 by 2, you get negative 2 square root 2 is your answer. Done. I want you to take the second problem. Negative 2 times cosine of negative 150. And I want you to do the same thing. We don't like cosine of negative 150. Change it to the cosine of its reference angle. And then use the appropriate reference angle or triangle to evaluate what's your sine. So, we're going to leave negative 2 alone for now. Yes? We're going to deal with graphing a negative 150 degrees. And if I graph a negative 150, which way am I going?
Going down.
Okay. And which quadrant? Somewhere about here, right? Form the triangle. What's the reference angle? This is negative 50, so the reference angle is not negative 30. Just going to be 30, because it would take me 30 degrees to get back to the x-axis. That is my reference angle. This is cosine. Cosine in the third quadrant is negative. So guess what? The negative of the cosine cancels with the negative of the front. So this would be 2 cosine of 30. And what happens to be the cosine of 30? Wait a minute. That's the other reference triangle I don't have written, so 30, 60, 90, 1, 2, 3, square root. Remember, we draw that the exact same way every single time because you're less likely to make a mistake, and then we can move it from there. But cosine of 30? Yeah, so it's 2 times square root of 3 over 2, which then equals just square root of 3. Easy enough. Yes? So, we don't like cosine of 300. 300 is fourth quadrant. There we are. Has a reference angle of 60. And wait, cosine in the fourth quadrant is positive. So that means this would be the same exact thing as 5/3 cosine of 60. I like this because then I can go to my reference triangle. 60 cosine 1 over 2. Hey, that's really nice. Bless you. What's 5/3 times 1/2? 5/6. And you're done. Homework is the worksheet lesson 27. Have a great day.